already I explained you general solution of the linear differential equation of higher order. Complementary y equal to yc plus yp, complementary function plus particular integral. So far we have discussed complementary function. To calculate the complementary function, the RHS side in place of q of x I kept 0. Like that we will calculate the complementary function by taking 0 instead of q of x. Suppose if you want to calculate the particular integral, means the general formula of the particular integral is 1 by f of d into q of x. This is the general formula of the particular integral. Therefore yp equals to pi equals to 1 by f of d into q of x. Means here d is nothing but capital D. Means by using differential operators, d equal to d by x, using that differential operator, the given differential equation we are converting in terms of capital T. After conversion of this one, f of d, we will get f of d separately. While solving the problem, we can see that f of d very clearly. Now this method is, I am taking general method, means up to n terms. In our problem mostly 3 to 4 terms we will get it. Just try to understand the topic, then how to calculate the particular integral while solving the problem very easily we can understand. And this method is also important. By using this method only we can solve the problem. Now the method 1. The general formula is 1 by f of d into q of x. That is the particular integral formula. In place of q of x, we have e power x. Suppose that is method 1, particular integral. Suppose in place of q of x, if you observe sin bx or cos bx, means sin 2x or cos 3x, like that type of term. Means sin bx and cos bx, that is particular integral of type 2. In place of q of x, if you observe polynomials, means x square, x cube, x square plus 2x, if you observe this type of term, this is nothing but particular integral of type 3. Type 4 is e power q of x equal to e power ax into v of x. Type 5 is x power k into v of x. Like this we have 5 methods. In these 5 methods also we can solve differently. We will convert. If it is not in type 1, we will convert into type 2. Now I am going to explain first method. Method 1. Q of x equals to, if q of x equal to e power ax, then the particular integral formula is yp equals to 1 by f of d into q of x equals to 1 by f of d into e power ax. The same thing, in place of q of x I have taken e power ax. That's it. Means wherever d is there, in place of capital D, you substitute the coefficient of x in e power ax. What is the coefficient of x here? A. Means the answer is 1 by f of a into e power ax. Particular integral. Direct. 1 by f of a into e power ax. This is the particular integral. This is the answer. When the denominator part f of a not equal to 0. Note 2 in this note. Suppose while substituting like this, suppose if you got f of a equal to 0, the denominator part f of a equal to 0, then what is the procedure? The procedure is factorize f of d in the form of d minus a whole to the power of k into pi of d. Means you should factorize in this manner. Definitely we will get in this manner only. Then how to calculate that I will explain you the technique while solving the problem to problem. It is different. Then if that 1 by f of d into e power x can be written as that equal to 1 by d minus a whole to the power of k into pi of d into e power a. Now again if you are substituting coefficient of x a, that coefficient of x is a in this d minus a minus a equal to 0. The denominator part is 0. If this part is 0, what is the power of d minus a? K. Means instead of that one, I will consider x power k by k factorial. Which one is 0? Which factor is 0? You see the power of that factor. If the factor is 0, when you are substituting coefficient of x, a, means that part d minus a whole to the power of k, that part is 0. Means the power of that factor is k. Means if the power is 2, x square by 2 factorial. Here the power is k is there, x power k by k factorial into, again the same thing, 1 by pi of a. In place of d, I am substituting a again, pi of a into e power ax. Here again pi of a not equal to 0. Definitely we will get pi of a not 0. If it is 0, then again we can know already as possible as we have factorized in the form of d minus a whole to the power of k. Definitely pi of a not equal to 0. This is the procedure. Once again, in this q of x equal to e power ax, just in place of d you substitute a, coefficient of x. Means 1 by f of a into e power ax. When f of a not equal to 0, this is the answer. Suppose if f of a equal to 0, then you take that denominator part f of d, you factorize. How to factorize I will explain in the problem. Don't worry, by using calculator we can calculate it. F of d equal to d minus a whole to the power of k into pi of d. Means wherever f of d is there, simply you write this term. Means 1 by d minus a whole to the power of k into pi of d e power a. Means the answer. The power, this factor is, this part is 0, the power of this part is k is there. That's why x power k by k factorial into 1 by pi of a into e power ax. This is the particular integral when q of x equal to e power ax. This is method 1 particular integral. Now, method 2 particular integral. Suppose q of x equal to sin bx or cos bx. Sin bx or cos bx. Next, the general formula, what is that? 1 by f of d into q of x. This is the formula for particular integral. Means in place of q of x, I will write 1 by f of d into cos bx or sin bx. If it is like this, directly replace d square by minus b square. Replace capital D square by minus b square. This is the standard procedure when you observed sin bx or cos bx. Replace d square by minus b square. Here minus b square means, you observe very carefully, it is not minus b whole square. Minus is outside b square. If it is cos 2x is there, the answer is minus 2 square means minus 4. If it is sin 3x is there, minus 3 square means minus 9. Like that you have to observe. This is very important. Here also the denominator part is not 0, this method is applicable. If the denominator part equal to 0, then we can use two important formulas. Directly using those two formulas we can solve the problem very easily. Means when you are replacing d square by minus b square, denominator part is not 0, then you continue the procedure. If the denominator part is 0, then go for the two important formulas. Those two important formulas, once again, 1 by d square plus b square sin bx. 1 by d square plus b square sin bx. In this particular integral, observe this one. Replacing d square by minus b square means the denominator definitely it is 0. Means if it is denominator part is 0, direct answer is minus x by 2b cos bx. Minus x by 2b cos bx. Formula once again, 1 by d square plus b square sin bx equals to minus x by 2b sin cos bx. Minus x by 2b cos bx. Second formula, 1 by d square plus b square into cos bx. The answer is x by 2b sin bx. These two are the formula. Once again, in this, if q of x equal to sin bx or cos bx, the general oral method, replace d square by minus b square. If the denominator part is not 0, then continue the procedure, automatically we will get the answer. If the denominator part is 0, then these two formulas are very, very important. 1 by d square plus b square into sin bx is nothing but minus x by 2b cos bx. This is the direct answer. Next, another one is 1 by d square plus b square cos bx. The answer is x by 2b sin bx. This is the method to particular integral. Third method. Suppose q of x equal to, if it is in the form of x power k, means x square, x cube, x power 5, like that. Then if it is in that form, the answer. The general formula of the particular integral yc equal to 1 by f of d into q of x. 1 by f of d into q of x. Means 1 by f of d into x power k. If you want to solve this particular integral, we have some important formulas we have to use. By using those formulas, we can calculate this particular integral. Means the first formula, 1 by 1 minus d. 1 by 1 minus d. If it is in that form, then the formula is 1 minus d whole inverse. When you are sending 1 minus d whole up, then it becomes 1 minus d whole inverse. The answer is 1 plus d square plus d cube plus so on.